Get the first slide, Toby. So this is us. My name's Ian Cooper, and that's Toby Henderson. And we work at Huddle. We're lucky enough at Huddle to get 20% time to work on open source projects, things like that. So we've been spending our time on this project Brighter. Okay, so what is Brighter? So we tend to like to have the layer boundary using command pattern. And particularly though, rather than just simply using the command pattern to separate the invoker and the receiver, we quite like to use a dispatcher pattern, which you can kind of see on the right-hand side. And the dispatcher pattern separates not only the invoker and the receiver, but it separates the command arguments from the actual handler. And that just means that essentially the caller is decoupled from understanding who actually services that command or how many people service that command. We also like to use a command processor approach. So the command processor says, well, when I'm running one of my commands, maybe some orthogonal things I want to do, logging, I may want to basically provide support for undo operations, may want to look at retry if I'm calling something across a network that could fail. We combine these two ideas, so we actually say, well, what we want to do is construct for you, you give us a target handler for your command, and we'll create a pipeline of other handlers based on attributes that you give us that allow you to have those orthogonal concerns as part of the pipeline. So Toby, you want to flip? Okay, so to that pipeline, here's what people call the Russian doll approach. So each successive handler is called in the scope of the previous handler. And that's really important to us because it allows us to essentially do things like have a try-catch loop in one handler that basically affects lower handlers in the chain. And we use, you probably can't read it very easily, but there's a library called Poly. It's another open source project we use to provide retry and circuit breaker approaches. So you can just tag a handler with use policy, and you can use things like retry and circuit breaker on that whole handler. So we'll rerun the whole handler for you X many times, or we'll break a circuit for you. We also support task queues. So we're really looking at things like Celery in the Python world is what we're trying to model. So we're saying, hey, that handler doesn't have to live in process. It could live in another process, for example, a Windows service. And we'll communicate with that other process and send your command to it directly over a broker-architected message queue. So we use RabbitMQ, which is what we've got support for today, but we're slowly looking at rolling out for other MQP protocols, like, for example, Azure Service Bus. So you can actually just send something to another handler and run somewhere else. So it's pretty seamless. We take care of nearly all the infrastructure in between. So you just write your handlers and deploy them in one, either in process or another service. Okay, where are we in this project? We use this now in production. So we built originally a similar project, and that project effectively we learned a lot from. So now we run this version effectively in live. We put about 30 million through it, and we pushed it back into production. So Toby's going to demo some code for us. Switch over. So you want to kind of show you what it looks like. All these examples are part of the GitHub repo. We just wanted to show you a couple of simple examples. So we're using essentially in this particular example is a kind of fake task application, and we're using OpenRaster as our API handler. But here you can see what happens is we get basically a post in, and we create a command from it, and we send that out of the command processor, which goes to a handler. Toby, can you go to that no, we could go to the handler for the command processor sending to. Okay. So that handler there, you can see essentially receives that command. We find that by the dispatcher, it looks that up for you. And you can see we've tagged it with a number of attributes that provide request logging, some validation of the command, and actually provides a policy, which is basically using that poly process to actually say, we want to retry this if it fails a certain number of times. Okay, we can then show you an example of, so here we're showing an example, we use post rather than send. And what we mean there is we're going to send that out over a distributed task queue rather than in process, so we're going to run it in a separate process. So look at the handler for that maybe, or can you go to app config? Okay. So we've got a separate Windows service running, and that Windows service essentially has this connection, and that connection tells it basically that when you see a message with this topic, turn it into a command of this particular data type, and then process it. So we handle that work for you. I think you can probably show the handler, which you run. Essentially looks just like any other handler that you've got. Just run a handler. Just looks like any other handler you got. We got basically two policies on there. Sorry?
30 seconds.
Okay, great. We're going to just show the rest of the slides just quickly. One, two. Okay, next slide. Okay, where do you get it? Basically, go to GitHub there. You can basically grab The actual source code and the documentation lives there. We've got a fair amount of documentation now. You can get a NuGet, obviously, and do an install. And the final thing to say is, next up for us is a whole lot of management tooling and monitoring tooling. So we're targeting Hystrix. That's kind of what we're looking at, which is basically what Netflix uses basically to run. And we're going to try and model some more of that particular stuff. We accept issues, PR requests. Come and join us. Lend a hand. Okay. Well, quite tight, but...